Let's talk a little bit more about the gamma distribution and MGFs. So now we're going to have two gamma distributed random variables. So x is going to have a gamma distribution with parameters a and lambda, and then y is going to have a gamma distribution with parameters b and lambda. So let's also assume that x and y are independent, so x, y independent. Well, we already know that the MGF for x is equal to 1 over 1 minus lambda to the times t to the a, and similarly, the MGF for y is 1 over 1 minus lambda t all to the b. Now we're going to see that the MGF of x plus y is equal to 1 over 1 minus lambda t all to the a plus b. All right, so let's see how that works. So first, let's just start with definition of MGF of x plus y. So we do this, and we know that if we have e to the something plus something, we can split it up into a product. So this gives us e to the tx times e to the ty, and we're taking the expected value of that entire thing. All right, so this is just going from here to here, just an algebra rule. And then going from here to the next step, we're going to use the fact that x and y are independent. So x and y being independent means we can split up this expected value into the product of expected values. All right, now let's just use what we already know. We know the MGF for x, that's right here, and we know the MGF for y, that's right here. So we have something to the a times something to the b, and these are the same somethings, so that gives us that thing to the a plus b. All right, so now we have found our MGF for x plus y, and it is what we claimed it would be. It is 1 over 1 minus lambda t all to the a plus b. All right, so our proof is done. All right, so what that means is x plus y has a gamma distribution with first parameter a plus b, and then the second parameter is lambda. All right, so here we had two random variables, x and y. Let's generalize this a little bit further. If we have a whole bunch of random variables, and they all have the same second parameter lambda, and then they have potentially different first parameters, so maybe x1 has parameter a1, x2 has first parameter a2, and so on. And furthermore, if the x's are independent, then the sum of those random variables will have a gamma distribution. And the second parameter is lambda, which is our shared second parameter for all of those x's. And the first parameter is just going to be the sum of the first parameters.